Okay. Hello, everybody. Welcome to my presentation, and it will be called Live Updating Swift Code. My name is Bartosz Polaczyk, and I work as Senior iOS Developer at Railwayman. And here is the agenda of my talk. So instead of first giving you the theory and then go with real-world scenario, I will revert the order and first give you a demo and hopefully take your interest, and later describe what actually is going under the hood and what are the limitations we have to consider when trying to inject Swift code. So let's start with a demo now, but instead of first demo, I would like to just introduce briefly into a tool called Injection for Xcode. Some of you may know it, some of you may be even using it every day, but this is actually an application. It's an open source application that you install as an external app independently of Xcode installation, and it's totally headless. It sits in a menu bar, and what it actually does, it just pulls out your code, .m or .swift from Xcode, compiles it, and injects into a simulator. Only simulator is supported, devices are not supported. And as you see, this is kind of a hot update in your application. You don't have to rerun, rebuild everything, just to speed up your development process. And as I said, it works both with Objective-C and Swift. However, for the purpose of this presentation, I will concentrate mostly on a Swift. And this tool has been done by John Holdsworth. This quite old tool. About 5 years ago was the first commit there. But John updates to the newest version. So nowadays, Swift 3, Swift 4 is supported, Xcode 8 and Xcode 9. And you can also use it with the older Swift version. So don't worry if you haven't updated your code base into Swift 4 yet. Okay, so let's go into a demo now. So let me show you. Let's increase a bit. Yes. We have very simple application created just from a wizard. It's very basic. I mean, there is just a navigation controller over here. It's a starting screen. And there's another one that we're pushing into navigation stack controller. And you will see here the code of it. So the second screen. It's very simple. What we do, we just take a UI label and update the text there, sample. Really simple. And we will take a scenario where you're in the development process and you would like to update something. You wanted to change the color of a label or something like that. So I will just demonstrating by changing the label text live. Okay, so let me run it, build it, and I will show you that the actual application really works. Yeah, we got the next, and you see here is just the label. Okay, let's leave it here. And I'd like to change from text from sample to sample new, for instance. And what I will do, I will try to inject it live while the application is still running. Yes?
Can you make the label bigger in the app?
I can make a simulator bigger if you want it. Is it better? Cool. So I'm saving now. Let me enable, here. And here is this magical inject for Xcode tool. And there is a shortcut. It's a control and equal sign. So I will just press it. And now starts the entire magic. There's a lot of things are doing. And we here see the current update. Status is swizzled this view controller. So let's go back. Nothing has changed. Let's go switch pop into view controller and boom. it has changed. Implementation is new. But you may be wondering, this is quite tedious process to go back and forth to reinstall, to reinstantiate the view controller. But there is a remedy for that. There is a special method that you implement, and you can do whatever you like inside this function. And for instance, you would like to update some view. I mean, this is something, the place that you want to do every time the new class implementation is swizzled, it's injected. Okay, so let's try with something new, new tool. And you will see that I will not have to go back and forth in navigation controller. So I will just command save and inject and boom. So this is how it actually works in life. And if you are really brave, you can also enable file watcher here. So every time you press a command, you save a file, it's updated for you. So you can just develop and watch what's going in a simulator live. So I suppose that you've already seen the great potential for increase your time of developing rather than waiting for a simulator. And as I promised, let's go back into slides. Okay, so how does it work under the hood? What we wanted to achieve in general is to replace the implementation of our class, blue box, in a runtime with a new implementation. Let's assume we have already, somehow we just achieved injection bundle and we've got new implementation of this class and you want to just override it. Okay, how does it work in Objective-C? That's really simple because Objective-C uses static message dispatching. And what does it mean? It means that every time, I will maybe come back a slide. Every time you call a method in Objective-C, a special message is created and includes also the string value of the method you wanted to execute. Of course, you've got inside this message also all the arguments. And this message one is sent to the instance that we want to call on our method. So as you see, this is very dynamic, so flexible. You can exchange in runtime. You can do everything that you want to achieve some hacky things. And I think most of you know it as method swizzling, and this is actually what injection for Xcode does. So I'm pretty sure that you recognize this method exchange implementation, and it will just take the same selector from the old implementation that we've got in runtime currently with a new class from different other class, and we are swapping on the implementation. This provided by Objective-C runtime. We can say that's very easy, the swizzling in the Objective-C. I didn't say that how did we achieve this magical bundle, but the swizzling in Objective-C, it's not a rocket science. So let me just update this animation a little bit. So we've got here injection bundle, and we are iterating all one by one, all the methods, and we are just swapping those implementation. This is how it works. Fortunately, methods and also getters, setters are also under the hood. A method implemented as method, that's why everything works magically with those methods swizzling. Okay, now let's move into Swift. And with Swift, it's not so simple because in Swift we don't have only message dispatching, but the different kind of dispatching, like table and static. If you're not familiar with table dispatching or static, what it is, I really recommend you the article blog post by RaiseLab. I will give you references at the end. But in short, it means that if you have the table dispatching, it means that within the implementation, the code, Swift code, looks up the special table for where is the pointer, where is the memory place that we should run the instructions of given function. So that's one source of truth when we can just replace maybe something. It's possible because there is one place to exchange, swap implementations pointers. But with static, it's a little bit more deeply embedded into assembly code, and it means that there is no single source of truth. The code, the jump to a real implementation is just tied together with the assembly code. I will describe it in details in a moment, but let's think about memory Swift class layout. So class, every single class in Swift has this kind of lookup table, and it includes a lot of different metadata that I just skipped in this slide, but it includes also some pointers to the functions, like there's a function viewDidLoad or function return something. So this is a pointer in the lookup table for memory address where the all assembly code sits. So let's think about injection for Xcode. What do we have to do? Of course, we've got a completely new implementation, new memory. It sits in a completely different area in the memory. So we can just replace just the pointer so that it points to a completely different place in memory. And indeed, this is how Swift works with table dispatch. Let me just zoom in into the most important function here. It just takes one table and second one and just copy memory from each other. That's why in a runtime we've got new table and new pointers we are using in our code. You don't have to just read what's going on. It's kind of code that usually you don't use. It just works. And so far so good. We can do something with table dispatch, but how about static dispatch? I just introduced you a little bit into the problem of static dispatch where we don't have such one source of truth, but let me just describe it in detail. So we will have some class, just as an example, and those white bars correspond to assembly code, assembly instructions. And we are assuming that the class would like to call some method on a struct. And for value types like structs, enum, those are examples that Swift always uses the static dispatch. So there is a jump, assembly code jump into place in memory where the implementation of a struct sits. And after implementation, after the function is done, instruction pointer is returned back into class. So as you see, we cannot just take the machine code and try to tweak it out, something to replace those jumps maybe into the completely different area. That would be too dangerous. And this is actually the reason why injection for Xcode does not support swizzling the structs and enum. In general, all those forms that require static dispatch. So at the moment, let's try to summarize all the limitations that we've got. With Swift, with Objective-C, all the classes are working fine. So first one, if we wanted to swizzle in Swift, classes have to inherit for n as object. Those have to be non-final, have no final methods, no structs, no enums, no extension, just because those are using static dispatch. By the way, you also cannot swizzle global functions, and this is important, you cannot add any method or properties if you are just swizzling. I mean, you cannot just extend the class with an extra method. And as you see, that's a lot of limitations. And you may think, what left? What can you do in Swift? So if you think about it, this is actually something that I wanted to tweak, change the implementation of the code that sits and calls the UI kit. I mean, the UI view controller, for instance. It inherits from an as object. Usually it's not final, and without adding extra methods. And generally, this is the reason why John created the injection for Xcode. And let me just add, it has also some magical feature that it will also inject your interface builder, Xcode storyboards. So as you see, John wanted to give us a great tool, but for long-lasting process on creating, tweaking the UI. Okay, we can think that's cool, but at the moment, we are developing not in massive view model view controller, and we very often use MVVM or Viper, where view model or interactor, it's just a plain class, not inherent from an as object. And therefore, injection for Xcode, it's not so useful in our daily basis development. So that's true, and there is one but. And here comes the main part of my presentation. And I'm very thrilled to present you for the very first time in public my addition into injection for Xcode. And this is called InjectionTDD. And let's think what it can do. The name suggests that it has something to do with injection, live updating of implementation, and with TDD. So with some tests. So what can it be? This is auto-updating of your tests, running them live while UI making some changes. And everything here is in our Xcode interface. So this is something that it's a continuation on Marek's presentation or during last Cocoaheads. And I will also try to give you a demo first. How does it work? Okay. So I have the same project that in the previous demo. And there is one addition I had to do. I added here InjectionTDD framework into a test target. So this is one requirement that you have to fulfill. And also, if you're having CocoaPod, you can also add into your pod file one line pod install, and it's ready for making your TDD development. Okay. So let me add some implementation here, because it's very simple. We can just here inject, just to be ensured that we've got up-to-date version. Correct. It's just addition is very simple. The function return A is returns A, B, B. And let's write the test, cover it with a test. And also very simple test that verified. There is a return value from return A, the string A. And I will now inject. Did I forget about? No. Let me try it from scratch. You will see that there's kind of weird behavior, but I also have different demos. Okay, I know what was my mistake. I previously kept the simulator run with Command R, while you always have to run Command U. That's why then you're running the test target. So we are injecting here my implementation takes a while. And as you see, here we've got a notification that the test succeeded. And if I just add something, print command S, remember I have still file watcher, and this presents me some problems. What was wrong here? So value ABB is not equal to A. So all the interface is given us within our beloved Xcode. Okay, first demo, but I said that in Swift we are not using UI view controller that inherits from an as object. How about plain class that I will add here? So let's add new class, for instance, some view model with a Swift, of course. And I've got ready here some view model implementation and add some tests for that. Remember that every time you're adding an extra function into the project, extra file into the project, you have to rebuild everything. I will describe you why do we have to do that later on. But nowadays, let's create a view model tests also in Swift. Let's add to target, right? Standard import and replace implementation of it with also very simple test. So let's run it. Remember, Command U. Now it builds in a simulator because this is just a normal test target. And once you see here a prompt ready for injection, you can start your injection. So view controller, okay, still makes those things, but only here. Command save, and yeah. Remember that we had two kind of files. Not all the files are, or not all the tests are executed because those could be long-lasting tests, and we wanted just to update those tests that could be breakable because of your change, or something that we fixed in our swizzling, in our injection. Okay, I will add you an extra, more difficult task. So static dispatch. Remember that if we are using structs, we also having a static dispatch, as, for instance, enums. So I will add here some struct. Is it some struct? Okay, and let's add some unit tests for that. Okay, this is including the class, and don't remember about the table. Import. Command U. You see, it takes a couple of seconds to build everything if we wanted to rerun those tests, but this is something that we do only once. Okay, so we are here having the struct. I can, for instance, inject to test if the tests are also succeeding. We've got one test, 0 failures, and here notifications as well. So let's change something in the struct. So we are using still static dispatch. I'm saving, and failure. It works. It also works for static dispatch. We see here, of course, everything is in the Xcode. But also, I said you that you in Swift, with injection for Xcode, you cannot add any additional methods, properties. Okay, let's try if we add some additional test. We are still running in a simulator. And we've got now 2 tests. So as you see, it should be here updated, but not this time. Usually, yeah, it also exists in the navigator. So we added a new function, and it's appeared here. So you can add extra tests. You can add extra functions in your application, into your implementation, and it will also work. Okay, so that was my demo, and now let's go back to slide to demonstrate what actually is going under the hood. So let's summarize everything. We saw the InjectionTDD. This is a addition into injection for Xcode that runs your live unit tests every time you save a file, for instance. It requires 0 configuration, or very minimal, because the only one thing you have to do is to include this .framework there, or add an extra pod, 1 line of change. And all the interface feedback for you, it's within Xcode. And remember often that it uses only Swift. InjectionTDD uses only Swift, so both implementation and test have to be written in Swift. So that was a lot of things. I would just give you an overview, broad overview of an entire injection that happens in the demo that I presented you. So every time, every day, if you are running command B, command R, command U, Xcode creates the build log. For every build, it adds some logs. Those are files that sit in your derived data directory. Usually you don't read it. It's a binary file, and it is intended to be read by Xcode. Okay, we know it. Let's skip it. And also, if you are running a simulator process like command R or command U, there is in a simulator, of course, the application starts, and also LLDB connection is set up within Xcode and your application. This is standard. And now comes injection for Xcode tool. What it does? First, it sets up completely new LLDB connection into the simulator, and instruct the application there to connect with application injection for TDD using TCP sockets, so that LLDB connection can be closed, and all the communication between InjectionTDD and your application simulator happens over this channel. It's still live, still going while you're doing InjectionTDD. What's going on next? Then InjectionTDD has to recognize what was the last recently file saved in Xcode. Okay, returns a path to this file. Then it scans all the build logs to find an actual Swift command that compiles it. Okay, and once we have this command, it can, using the same command taken from a build log with very small modifications, build it again. Only this one particular file that has been recently saved in an Xcode, and it has some .o file as an output, and it would like to inject it into a simulator process, but of course .o we cannot just load from a process. That's why it creates an injection bundle that I will describe in next slide how it's done. But once we've got it over TCP connector, it forces it to load it dynamically. So every time I showed you command S and new injection is going under the hood, the new bundle is created and the application has to load it dynamically. I promised short overview of how does the injection bundle is created. So we've seen that from build logs, we've got some commands that we are calling them, and as output, we've got several .o files. Those are binaries. And I showed here 3 files because we can have implementation file, but also some tests. Some tests that we found that are actually calling the methods, calling the symbols that we are implementing in the first file. That's why those tests can be finally passing or failure because of your mistake. And those files .o are later on linked by completely external, invisible for you Xcode project. So it sits somewhere, you never see it unless you ask for doing that. And the aim of this project is only to create injection bundle. So you see a lot of different technologies are involved. It involves C, C++, Objective-C, some Swift command, LLDB, what else? Yeah, parsing those binary logs using Perl. There is a TCP connection that we have to all the time keep running, loading a bundle, and then also some extra swizzling that I described at the very beginning of the presentation. But it just works thanks to John Holsworth's great tool. You may be wondering, how do I know which actual test should I run? Because I said not all the test cases are run if you're saving a file using Command S. So hopefully, every time we create a single, we are executing or compiling that .swift file, it creates an extra meta file. And let's concentrate on 2 sections there. It looks like a YAML file. And first section is provides member. So as you may suppose, it's all the symbols that given file implements, provides to the entire runtime. And it also has a depend stop level. So opposite, on which symbols this file actually is working on, using them, calling. And if you are familiar with mangling, name mangling, this is something similar. So here, for instance, we know that this reactive Swift is a name of a module, and the 13 here is the length actually of this string, length of its characters. A signal producer is the name of a class, and unique value, it's a name of a function. So this file assumes that there's somewhere this file implemented. Okay, this is something I wanted to now describe about static dispatch. How does it actually work? I said that it's hopeless. Within Swift injection, we cannot just change some implementation there. So let's think again, what's going under the hood if we are injection tests. So let's assume that this class is an XC test. So it has injected, embedded the memory address where it should jump into a struct implementation. And what we are doing in injection for Xcode, we are injecting both the tests with a new implementation, and there is completely new test, and it also has a jump, but now it has a jump into a newer version of a struct. That's why we don't have to do it. The test actually depends on the up-to-date version of a Swift struct. And unfortunately, there are some limitations that I wanted to warn you now. And InjectionTDD does not work with Objective-C. I've said it already. Your implementations and tests have to be written in Swift just because this is how I can recognize or infer the test that I should run after your injection. You cannot use static libraries in your project. If you're using some, then unfortunately you have to think about it if you should replace it, at least only for developing using TDD into dynamic libraries. And it's also required that your test target has a host application. So you had to add for test target, the host, just because there has to be some application on the front so that injection for Xcode can connect to using LLDB. And remember that every time you add extra file into an Xcode project and you wanted to inject it, then you have to restart the test again, just because otherwise I wouldn't be able to recognize what's the actually command, Swift command to compile it. I really encourage you to try it out if it's working for you, if you've got some troubles. So how to proceed and start using it. So first you have to download injection for Xcode. But this version that uses TDD, so you're going to the John Holdsworth web page. I will provide you a link, of course, afterwards on our meetup comments. And remember always to take the version supporting TDD. Then be ensured that your Xcode select version is the correct one, this one that you're currently using. And to integrate, of course, you have to use, for instance, pod. And it's called InjectionTDD. If you are using Swift 3, then the version should be 0.3. If you are using Swift 4, 0.4. Quite easy to remember. But of course, also all the installation process steps are available for you in the GitHub repository of this project, which I will also give you a link later on. And then you're ready with command U. You're ready for injection prompt, and you're done. You can start implementation. And one small recommendation that usually you shouldn't inject your test. Just try to first inject the implementation, real implementation, and just depend on the tool itself so that it infers which one test should it run. Usually it works if you are injecting the test, if you want to, for instance, change some kind of test because you recognize you've got some mistake there. But if you've got some trouble, go back into implementation and from there inject a new file. One extra thing, if you want optionally to have this nice notification, this is actually implemented as a Xcode breakpoint. It's a breakpoint that has AppleScript as a command that's going whenever you reach given point, the symbolic breakpoint. It's quite complicated, and you usually don't want to think about it. Of course, you can just the text that is used there you modify, but usually you will leave it as is. So there is a command that you have to run, and of course it's available on the GitHub of the InjectionTDD project. So let's summarize. I presented you first injection for Xcode, standard, already existing application that you could be familiar with, and I demonstrated that it works nice with UI. But I also showed you my addition for that, called InjectionTDD, that you can run your tests every time you save the files, update it. It requires very minimal configuration, and all the interface that you're working on, all the feedback is done on the Xcode interface. And here are the references. So, of course, the link to my GitHub project and the place where you can download the application of John Holdsworth. And also, I mentioned also about this RaiseLab blog post about method dispatching, also recommended. This is something that you should have in your toolbox. You should be aware of what's going under the hood. And also very nice video by Mike Ash. How does a class lay out in the memory? And thank you very much. And now for questions.
Wow, that was amazing. I think everyone thinks the same as me. So, do we have any questions?
So my question is, so you said that there are technical problems to implement the injection in Swift, and the author of Xcode Inject couldn't do that. So So with this presentation, you just presented that you did what the author of Xcode inject couldn't do. Can you explain that?
So there is one difference between me and John. I'm doing only for X test cases. I'm not swizzling everything in your application. So all the UI is still using the old version of your structs. Only the tests are using the correct one up to date. So I didn't do any rocket science that John couldn't achieve.
Okay, thank you. Second question, I have second question if I can. So this is like the everyday work that you do at Railwayman, this kind of scientific research on how Swift and memory layout works. It's not a question. You don't have to.
Rhetorical question, okay.
Thank you. Good.
Thank you.
Anyone?
You said that you need to set the host application for unit tests to be able to use your version of the injection. But what if I'm writing unit tests for a framework target? Can I do that? Because I'm not sure if I can set the host application for a framework target.
So you've got exactly the same configuration as Kickstarted. So they just had host application none. And what I had to do just to choose the application over there, and it worked. So unfortunately, now the normal tests are, of course, longer because the process of the application has to boot up. But it's not a blocker, at least in the example with Kickstarter that I work with to verify it.
Okay,
Thank you.
Any questions? No? So
There's one extra.
If there's no other questions, I used to use the Xcode inject like 3 years ago. It was for Objective-C, but I stopped because like the process, I felt that it didn't really speed up my process because of what I saw a couple of times on your demo. It was like this little pop-up that appears and tells you that something went wrong with the build. How is your experience with this?
So I agree with you that from the very beginning, that's quite steep learning. So the project at the beginning may not work. You don't know what's the reason for that. Maybe your Xcode select is invalid. I've got some different errors, like I was using not dynamic libraries only. But afterwards, once my project becomes stable, it works very well for me. So I use it very often in my daily basis, and my feedback, my opinion is very positive on it.
Okay, thanks. I will have to try it once again.
any questions? No? So thank you, Bartosz, for your presentation.